Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. The joint probability density function of x and y is given by f of xy equal to x plus y over 8 for x between 0 and 2 and y between 0 and 2. Calculate the variance of x plus y over 2. So note that the joint distribution of xy is symmetrical. That is, f of xy is, I like writing the random variables in subscript, so f sub xy of xy is equal to f sub xy of yx. It doesn't make any difference if you switch the variables. And this implies that e of x is e of y equal to e of y, and variance of x is equal to variance of y. We have, for x between 0 and 2, the survival function of x, which is a property that x is more than x, is the integral from x to 2 of the integral from 0 to 2 of s plus y over 8 dy ds. I'm not using the variable x in the integral because I have it in the limit of the integral. Because we're looking for property that big X is more than X. And that's the integral from x to 2 of sy plus half of y squared over 8, evaluated from y equal to 0 to y equal to 2, and then we take the integral of this with respect to s. So that's the integral from x to 2 of 2s plus 2 over 8 ds. And that's the same as the integral from x to 2 of s plus 1 over 4 ds. That's half of s squared plus s over 4 evaluated from s equal to x s equal to 2. That's 4 minus half x squared minus x over 4. So 1 minus 1/8 x squared minus 1/4 x. And therefore, e of x is the integral from 0 to 2 of that survival function. That's x minus 1 over 24x cubed minus 1/8 x squared evaluated from x equal to 0 to x equal to 2. That's 2 minus 8 over 24 minus 4 over 8, which is 3 halves minus 1/3, and that's equal to 7/6. And then the derivative minus the derivative of the survival function is the density of x, and that turns out to be 1/4 of x plus 1/4. And this also gives the second moment of x as the integral from 0 to 2 of x squared times 1/4 x plus 1/4 dx. So that's 1 over 16x to the 4th plus 1/12 x cubed, evaluated from x equal to 0 to x equal to 2. That's equal to 16 over 16 plus 8 over 12. Because it's 0, the value is 0, and that's 1 plus 2/3 or 5/3. And we conclude that the variance of x is the second moment minus the square of the first moment, so 5/3 minus 49 over 36, that's 11 over 36. We know that the variance of x plus y over 2 is 1/4 of the variance of x plus y, which is 1/4 of variance of x plus variance of y plus 2 covariances of x, y. And since the variance of x equals the variance of y, and it's 11 over 36, at this point we just need to find the covariance of xy. Well, the covariance is e of x xy minus the expected value of x times expected value of y. So it's e of xy minus 7/6 times 7/6. And we just need to find e of xy. Well, e of xy is equal to the integral from 0 to 2 of the integral from 0 to 2 of xy times x plus y over 8 dx dy. So it's the integral from 0 to 2 of y times the integral from 0 to 2 of x times x plus y over 8 dx. And then once we evaluate this, we'll take the integral with respect to y. That's equal to the integral from 0 to 2 of y times x cubed over 24 plus x squared times y over 16, evaluated from 0 to 2. and then the integral with respect to y. That's the integral from 0 to 2 of y times 8 over 24 plus y over 4 dy. So that's the integral from 0 to 2 of y over 3 plus y squared over 4 dy. That's y squared over 6 plus y cubed over 12 evaluated from y equal to 0 to y equal to 2. And that's 4 6 plus 8 12, so 2/3 plus 2/3, and that's 4/3. Therefore, the covariance of xy is e of xy minus 7 6 times 7 6. And that's 4/3 minus 49 over 36, and that's negative 1 over 36. And the variance of xy is equal to 1/4 of variance of x plus variance of y plus 2 covariances of xy. And that's 1/4 times 11 over 36 plus 11 over 36 minus 2 over 36. Well, that's 22 over 36 minus 2 over 36, so that's 20 over 36. So 1/4 times 20 over 36. That's 5 over 36. And that's the same as 10 over 72, which is the form of answer we have as answer A. Please remember this is copyrighted material. The problem itself comes from a Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.